Good afternoon. It's a pleasure to be here today in Sofia. You saw some very interesting examples of robotics. I'm going to talk a little bit more about what you can do today. In particular, I'm going to tell you about the future of automation, manufacturing jobs in Europe, what we see as trends at ABB, and also what we think is coming next and how it's changing the future of work. So, first of all, I want to start with a little bit of a history of where we are as a company. Let me just activate the clicker, please. Okay, thank you. So ABB is a company that's been around for 130 years. And 130 years is enough time to actually have been a key player in the second industrial revolution, the electrification movement, as well as the third industrial revolution, which occurred roughly around the 1960s and 70s with the advent of automation. And you've heard several speakers talk about automation already earlier today. And now we're heading into the fourth industrial revolution. And the main difference we see between the third and the fourth is systems that adapt and learn. As we saw examples of robotics, but also in general AI, which doesn't have to take the form of a robot, but can in fact be applied in a wide variety of contexts. We did a study in 2018 where we asked a very simple question. Along with the Economist Intelligence Unit, we said, are countries ready for automation? As you saw earlier from Paul's presentation, the changing nature of jobs is going to be extremely rapid in the years to come. We believe that most countries are not yet ready to fully anticipate the rate of change that is going to be caused by the advent of these new technologies. So what we did is we conducted a study for 26 OECD countries, and we asked questions in 3 domains. What are the countries doing to prime innovation? Are they investing in AI, automation technologies to try to spur ecosystems and startups to create the new jobs of tomorrow that are necessary to absorb some of the jobs that will be impacted by these technologies? The second question, what are they doing to retrain the workers that will be impacted by this, whose jobs will be changing as a result of this technology, to make them ready to adapt and to try to position them for the jobs that will be made tomorrow? And the third, what's happening with education policies? Not only trying to get everyone ready for university education, but in fact, primarily, how to train the workers for the factories of tomorrow, where we also have, in fact, a shortage of people qualified to do that work. And as you can see from this result, first place, South Korea, followed by Germany, followed by Singapore. The United States, where I currently live, is in 9th position. But if you read the report, there's no reason to feel good about this because, in fact, all countries were determined to be in a fairly unready state. And though even, for example, South Korea has a great ecosystem for driving innovation, has done a lot in terms of retraining workers, it has a system that gears up its workers primarily for universities, not for some of the more technical blue-collar jobs that we need for tomorrow. In Germany, there's a much better system for the vocational training, but very little in terms of spurring the innovation ecosystem that's required. And then in Singapore, they have a very innovative system whereby they give workers training credits so they can apply those credits to get the kind of skills they need to adapt to the changes in the workforce. So fundamentally, as a society, we don't appear to be overly well prepared for the nature of these changes. So what are these changes? And what I'm going to describe to you is the impact of 2 very innovative technologies. One you've already heard quite a bit around, artificial intelligence. The second, the concept of a digital twin and how that changes the jobs in the industrial sector. So if we think about manufacturing, and manufacturing even today remains a very large percentage of the jobs that exist in a modern economy, the manufacturing sector is under threat. When manufacturers are asked, what do you think the opportunity is for the fourth industrial revolution? The number one answer they provide is it'll help us reduce cost. The other reason why they like it is because they think about having greater agility. And what we see across the world is the cycle time to make products is being compressed. Consumers are global. They see trends. They want to take advantage of the new trends emerging. They want to buy those products today. So some of the companies, for example, are really stepping up their agility in response, such as, for example, Zara, headquartered in Spain. They can get ideas from the drawing board to the stores within 3 weeks, which is significantly faster than the many, many months that it takes most of their competitors. But the other thing that people now crave is individuality. The time of any color as long as it's black is no longer really interesting. People want to have it the way they want it, and they want it now. And lastly, we've seen a decline in productivity in the manufacturing sector, which is a real concern. It used to be, for decades, up until about the year 2000, that manufacturing productivity was increasing by 4% a year. Now it's effectively zero. If productivity does not increase, wages will stagnate. Stagnating wages will mean that, as you saw from Paul's earlier slide, people with higher education will probably thrive, whereas the middle class will get eroded. The blue-collar jobs that used to pay a reasonable wage will no longer do that. As a society, we can't afford to let that happen. And I think overall manufacturing is seeing that there is no option for inaction. I would say that much of the technology wave, the internet, the web, which completely transformed banking and telecommunications and the telecommunication or technology sector, didn't really affect manufacturing, but it will now. And that's primarily because consumers are much more powerful, they're in control, they want these changes. We also are being subject increasingly to regulation impact in terms of the use of, for example, specific conflict minerals or where those raw materials come from is an increasing interesting area, and people want to know, where does your supply chain extend to? The infrastructure is also aging. In the US, where I live today, the average age of an oil and gas pipeline is 50 years old, which is just about its useful life. And the workforce. We heard that earlier today from Dirk from Airbus. 40% of his workers are going to retire in the next 10 years. So we see that manufacturing is changing. And it's changing primarily because the information technology being applied means that the factory of the future is not this static machine that cannot be changed. It consists of robots, 3D printers, CNC machines, which can be reprogrammed at will. They can adapt. They can be reconfigured to make lots of new things. We're also seeing the advent of many new technologies. Manufacturing has been a laggard in technology that is now about to change. Augmented reality goggles are commonplace. In my own company, we have 40 different projects underway to allow workers to do the jobs of many individual specialists by donning these goggles and being guided to certain tasks. We're also experimenting with blockchain technologies to establish a chain of custody of raw materials and the supply chain. And increasingly, these digital tools allow us to design products with our customers, as opposed to in a traditional approach where customers give you feedback and then you try to respond to that and give them the product that you think they want. And lastly, all of these technologies are increasingly connected. These robots, smart machines, they're all increasingly connected to a network and to the internet. And as a result, cybersecurity is becoming a #1 issue. Because more and more, what we're seeing is cyber threats directed against industrial systems, not only the consumer technologies. And this is actually paradoxically a source of growth in jobs. Because in Europe alone, in the next couple of years, it's predicted there will be a shortage of 350,000 cyber professionals. So we think that the vision of the factory of tomorrow is that it remains digital end-to-end. We will design products digitally. We will also then be digitally commissioning them, which is, most people don't realize, when you actually want to assemble robots and put them into a factory, for example, it can take up to a year to configure a new assembly line. With digital tools, we can do that in half the time. And then lastly, as all of these products are increasingly smart and capable, we see the advent of new kinds of jobs. jobs which require teleoperators, people managing and monitoring this equipment from a distance. And in fact, this is where this technology of a digital twin starts to manifest itself. And I know this is a bit small from the back, but let me explain. Increasingly, what we will see is people will design or plan for a project using digital tools. That's 3D layouts, CAD/CAM tools, for example. They will then use digital project software to build it in real time, collaboratively with various suppliers and partners. Then they will operate this equipment, meaning they will monitor it remotely for certain attributes, making sure that it's not going to fail so that you can proactively maintain it. And then lastly, you can optimize, you can tune that performance of that machine, and all of that by having a digital simulation of what that actual physical machine and environment looks like. And this leads to all kinds of really interesting ways in which we can move jobs around. And what you see here on your left-hand side is one example of how we've taken an oil rig, which traditionally sits at the surface of the sea, and we have dropped that to the seabed. So now it's completely immune to storms and waves and all kinds of things. And this particular platform you see here is 3,000 meters below the level of the sea, sitting at the North Sea, right on the ocean floor. But of course, as you can well imagine, there can be no people there. So all of the interventions on that equipment have to be done on land, remotely. And we do that today. The other example is autonomous vessels. So while there may be a nice autonomous car outside, we think that the future is to make all forms of transportation autonomous. And one of the first autonomous ships has been enabled in Helsinki. So between the port of Helsinki and a nearby island, we have a capability to essentially pilot that ship remotely. And this is allowing humans to be on the loop, able to intervene and deal with specific corner cases. But to do that, we have to create more capable people. Because if you think back to over 100 years ago, we had teleoperators. We had people operating machinery, but they would be looking at a series of dials or displays of maybe 100 individual devices. That's the first control room. And then, as we digitized, we went to computer screens, able to manage thousands of devices. But today, some of our biggest installations, for example, a refinery in Saudi Arabia, we have over 150,000 connected devices. And clearly, human beings, we're not able to remember numbers, but we're also not very good at dealing with too many inputs. So we have to scale the people. We have to augment their cognitive capabilities with AI technology. And the AI technology will deal with the exceptions. And rather than the blonde robot you saw earlier, here are some of the ones that are actually in deployment today to help scale the people. Because what the robots do is they take this digital twin, the map they have of the physical world, and use that to navigate and to interact with the physical. So for example, we have our data center sheriff, which can install computers, remove power supplies, replace storage units in these mega cloud data centers, where there's essentially a lights-out operation, and this can happen without anybody having to actually walk through these aisles. Or the motor crawler, which goes inside of our large transformers, or motors rather, and can actually fit in the space between the coil and the actual outer housing. It can inspect whether or not that motor needs maintenance. A similar concept is the transformer diver. Transformers, or electrical transformers, are typically sitting inside of a bath of mineral oil. And if you want to do maintenance, you have to remove all of this oil and then eventually put it back. Instead, we can drop this little autonomous robot inside, and it has cameras and sensors, and we can pilot it inside. So this is where a human being actually navigates and controls the robot. And the last one is a special methane sensing robot, which can sniff out any leaks that might occur in oil and gas pipelines, for example. So we think that ultimately what's going to happen is we're going to see human beings extended with AI. And I'm not talking about brain implants. I'm talking about how certain tasks people are great at, such as looking at intuition, creativity, expertise. We're clearly not good at doing math, as we saw earlier today. The machines are much better at that, but they're not good at intuition, context, or connecting the dots thanks to experience. And we think the ideal combination is to combine the two. And that's why we think in the future, that's what we'll see. Thank you very much.